All right, everybody, we just got our okay to start our planetarium show. So for now, I'm going to be putting us into the unknown. Ooh. And good afternoon, everybody. Welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not a robot and AI yet. I'm a person. I'm standing right behind you at the very top of the planetarium. Hey, good afternoon, everybody. Good to see you. But don't hurt your necks. Look forward into the dome before you. Everything that you see in purple is going to be one really big screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. If you're looking for our projector system, it's hidden just below that purple glow. And folks, I'm happy to announce that the show that we're going to be doing is, hands down, my favorite show to do. This one is different from all the other ones that we've done here inside the Morrison today. This one's called Tour of the Universe. And this show is completely live, so you're going to hear my voice for the next 30 minutes. And we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just to let you know, we're pretty small in the grand scheme of things, so just a forewarning. And before we get started with the show, I do have to go over some quick house rules just so that we're all on the same page and have a good time. First off, folks, there's no food or drinks allowed in. If you brought any snacks, make sure those are put away till the end. We want to keep this place as clean as possible. Also, if you happen to have any cell phones, smartwatches, anything that produces really bright white light or loud sound, now is a good time to put those devices away for the next 30 minutes, as these can be very distracting and takes away from the planetarium show experience. And folks, if you need to exit early, the exits are always going to be at the very top of the planetarium, so always make your way up the stairs to exit. If the stairs are too steep for you, do not worry, just remain seated. Once the show's over, we'll have a staff member escort you to a lower exit once the show wraps up. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you have to do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. And it looks like we still have a good amount of cell phones out. Some folks ready to record. So once they put those cell phones away, we can begin our show. All right, folks, that's good enough. Let's get started with our tour of the universe. So I invite you to sit back, relax, and enjoy the show. All right, everybody. As I mentioned, we're going to be starting off pretty close to the Earth, but not right on top of it. We're starting off at this really cool spacecraft right in front of us called the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what's the International Space Station? I hear about it all the time in news and articles, but I don't really know what it is. Could you explain it for us? Well, of course, folks. The International Space Station is a research facility. It's a laboratory that orbits around our planet Earth, and they conduct so many different types of experiments up here. Some of the things that they'll conduct are things like what happens when you try to grow plants in space. Do the plants grow the same? Do they grow differently with less gravity? Another one is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently with that less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compare and contrast the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower, but not only that, you also lose a lot of muscle because you don't have gravity constantly working down on your muscles all the time compared to how it is here on Earth. And also, folks, the International Space Station looks really big here in our planetarium dome, but it's not that big in actuality. It's only about the size of American football fields. If you've never been to an American football game, do not worry. You can also use the entire museum, the California Academy of Sciences. That's roughly about how big it is. And what's really impressive is that this thing is traveling incredibly fast. It's traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises a day. Whew, how romantic. And also, this looks really far away from our planet Earth, but it's not too far either. The International Space Station is only about 225 miles above the surface of our world. 225 miles, that's not too far away. That's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend, so not too bad. But to tell you the truth, folks, this is as far as we put humans into space nowadays, only 225 miles above the surface of our world. The reason why? Well, traveling into space is very expensive. You have to build yourself a rocket ship, buy yourself one, or pay for a ride, and that's quite costly. And then you also need to account for all the rocket fuel to be able to escape the Earth's gravity, and fuel's pretty expensive today. And not only that, once you're out here in space, you have to account for all the food, water, all the air you're going to be breathing while you're up here, so it gets quite costly quite rapidly. But for now, folks, we're going to see the International Space Station slowly fade away to the city lights down below. Before we lose track of it, I want to add a nice little orbital path so we can see it as it slowly disappears. And now, folks, we're able to see our entire planet Earth from this view. And I want to let you know that the space program that I'm using here in the planetarium is something that you can go home and download if you want to fly through space, just like how I'm doing. What we're using in here is something called OpenSpace. So if you go to your favorite search engine, type in OpenSpace Project, you'll come across where you can download this, or go to OpenSpaceProject.com. And it's a really cool program. It's open source. Anybody can add to it, and it's free to download. Just a heads up, it uses a whole lot of processing power, so if you have an older computer, you may not want to try it on that, but if you got something new, a gaming computer, give it a try. It's so much fun. And if you don't want to download software, we also have another great alternative called NASA's Eyes. Just like the human eyeball, type in NASA's Eyes, and you'll come across a link where you can fly through our solar system, and it's so much fun, and you don't have to download anything. But in here, we're using OpenSpace. But now that we got a sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. And folks, we humans have been to the moon before. That was between 1969 and 1972. Thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years, thanks to NASA's new space mission in the works called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars. But before we send humans deep into our solar system, we got to figure out exactly how we're going to be living out here in space. And the moon is the perfect stepping stone how we're going to be figuring out the logistics, exactly how we're going to be doing that. And what's really impressive is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout our moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to conduct much more science in a much more compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found ice there, and we can melt that ice, pass electricity through it, separate the hydrogen and the oxygen, and both that stuff's really valuable when you're far away from home. So look out for any news about Artemis in the coming years. We humans should be heading back to the moon relatively soon. And folks, when we look up at the moon here from Earth, sometimes the moon feels really close. Feels like you can reach out your arms and touch it. But the moon's incredibly far away. It's about 240,000 miles away from the Earth. Whew, 250,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months non-stop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick, because at this scale, using miles is kind of like using inches to describe the distances between cities, because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so ever since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye-bye, moon. So cute. And now, folks, we're going to see the moon and the Earth in their orbits start to slowly fade away, just like how we saw with the International Space Station earlier on. And just like before, I want to add some nice trails so we can keep track of things. So here are the planet trails and moon trails, because again, space is so big. And folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer models like OpenSpace showing us the most accurate information and images available to us. And now the nearest star to us comes into view. So here comes that sun. Do-do-do-do-do. And folks, the sun is also incredibly far away from us here on Earth as well. It's about 93 million miles. Whew, 93 million miles. That's a good distance away. But in terms of speed of light, that's not too far away. It only takes sunlight about 8.5 minutes to travel from the sun to the Earth. And this is a really cool concept to keep in mind, because let's say the sun was to turn off its sunlight all of a sudden. That last bit of sunlight will travel that 93 million miles, that 8.5 minutes at the speed of light. Then all of a sudden, the daytime on Earth would become nighttime. And again, this is such a cool concept to keep in mind, because let's say we're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago, because the light that just reached us took 70 years to get to us. So when we look really far out into space and look at really distant objects, it's like looking back in time in a sense, which is really cool. But now that we have a nice bird's eye view of our solar system, let's do a quick refresher of what we have. Right in the middle of our solar system, we have our star, the sun. Closest planet to the sun, we have Mercury. Then we have Venus, really hot there. And then we have Earth. That's us. And after us, we have Mars, the red planet. Looks like my laser is slowly fading away. So these are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past Mars, we have the main asteroid belt. This is where you're going to find the majority of asteroids. There's roughly about 1 million asteroids in the asteroid belt, give or take. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We've got Jupiter, the largest of them all. Then we have Saturn, famous for its rings. And now we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto on screen, right in front of us in the center of. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. Yeah, that's a lot of stuff out here. So the Kuiper Belt's like a second asteroid belt. What you're mostly going to find are icy asteroids and short period comets that don't stray too far away from the sun. And what's really impressive is that our technology greatly improved in 2006, so we were able to see much more objects all the way out here. And in 2006, we found more than 400 objects out here, and some of this stuff was bigger than Pluto. So we couldn't call all this stuff planets. There was just way too many of them. So all the astronomers on Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet. And that was the day in 2006 where they came up with 3 different criterias. And that was the day that Pluto went from being a planet to a dwarf planet. But that's the really cool thing about science, because as our technology improves and we make better observations, it changes. So science is constantly updating and changing, which is really, really fascinating. But I'm going to put away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be adding on screen some many different spacecrafts we sent on the 1970s to explore our solar system and beyond. And now on screen we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. All of these spacecrafts are traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to get all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours. Not too bad. But now, folks, it's time for us to leave our planetary scale behind us because now we're heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And there's Alpha Centauri on our left-hand side of the screen. We can see that star that's moving much more than the others. And again, we're right in the center, right over here. And to the left, we have Alpha Centauri, that star that's moving really close. And again, 4 years at the speed of light just to reach the next star system to us folks. But that doesn't put it into perspective of how long it would take us humans to travel that distance. Folks, if you're getting into a spaceship today, make your way over to Alpha Centauri. It's going to take you about 8,500 years to make that journey. Whew! And that's just a one-way trip. But let's stop consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. And again, folks, we're now inside something called the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before the early 1930s, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year, so is anybody out there listening? And now, folks, I'm going to be adding these many markers onto the screen. These markers indicate the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that number is going to be increasing as the years continue because we have space telescopes that are being developed right now, and their whole purpose is to find as many exoplanets as possible. Now, to say if any of them that are Earth-like with conditions suitable for life, well, we cannot answer that question quite yet. Pretty much, again, new space telescopes are being developed, so we got quite a while before those are developed, launched into space, so we've got a little while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit within our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. And of course, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, I'll be putting away those exoplanet markers, but I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. All right, folks, we're now looking down on our Milky Way galaxy. This is the galaxy that we live in, and I've got to ask, can anybody see their house from here? Just kidding. And folks, our Milky Way galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light. It is really big. And the Milky Way is so huge, we estimate that there's at least 300 billion stars in the galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave the Milky Way, I want to show you what it looks like from the side. You're going to notice that we live in a big flat spiral disk of the Milky Way. Kind of looks like a big frisbee or a pancake in space. And this is important because when scientists and astronomers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking through the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. We like to point our telescopes galactically north and south. That's going to come important in just a little bit. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group, which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as our picture continues to expand, you're now going to realize that galaxies are not evenly distributed throughout space. There's not one galaxy here in a nice little line, another galaxy here in a nice little line. Instead, galaxies like to clump together in large groups and clusters, or they create voids, empty spots in space. So we can see some nice galaxy clustering towards the center of our screen. We see some voids on the left-hand side of our dome. So you can kind of think of galaxies like people. They like to hang out together, or they like to avoid each other. And folks, this picture that we're now looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing researcher by the name of Dr. Brent Tully, who compiled this amazing representation over decades of time with other astronomers working aside him. So big shout out to Dr. Brent Tully. I love flying through this galactic map. But now, folks, we have automated systems that are mapping you the most distant galaxies. So now we're about to see the very large-scale structure of the universe. And remember, every single point of light that you're seeing that's not a star, that's an individual galaxy. Whew, I feel small. And by the way, the large-scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I just mentioned that we live in a big flat spiral disk of the Milky Way? Well, if we were to line up our Milky Way, it would line up just down the middle, vertically, just like so. And again, we like to point our telescopes galactically north and galactically south instead of looking to the plane of the Milky Way. But scientists still want to make sure that there was galaxies through the plane of the Milky Way, so they have this nice purple survey of galaxies. You'll notice that they were still able to find them, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to map out all these areas that haven't been filled in yet. So it's just a matter of time. Whew, and speaking of time, looks like we're running close out of time. So let's continue pressing on, folks, because now we're going to be encountering these really distant, faraway objects known as the quasars. And the quasars are going to be represented by orange dots on either side of the large-scale structure of the universe. Here they are. And the quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe. What we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. All evidence indicates that the universe that we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And this picture is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color-coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these tiny differences eventually gave rise to that large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go. That's going to be back home towards planet Earth. So let's find a nice entry point to all these quasars and galaxies. This looks like a good spot. And let's make our return trip back to planet Earth, everybody. All right, everybody, we're across an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. We live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes. Preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we're making our way back into our Milky Way galaxy. We're heading straight for that radiosphere. And now, folks, we're going to be making our way to our solar system, our star system, our little neighborhood in the vastness of space. And now we're about to pass those spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto in the Kuiper Belt region, and making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, love, ever learned about in history all lived on this one planet. And now, folks, we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, this is going to be the end of our Tour of the Universe show. And folks, if you had friends or family that were unable to come and visit the museum today, you can share this exact presentation, this exact show with them, because this show is recorded and it's saved on the Academy's YouTube channel or the Morrison Planetarium's Facebook page. So you're more than welcome to share this experience with others. But hey, look at that. We made it back home safe and sound just in time for dinner time. And that's all the time we have for today, folks. Thanks for stopping by, and I hope you get home safely.